About acids, bases, and salts today. So we're starting with acids. You must be able to identify when you see a substance, is this an acid, is this a base, is this a salt? So what are the things you're supposed to look out for? What are the things you're supposed to watch out for that can help you identify if this is an acid, a base, or a salt? Those are the things I will be dealing with in this class. I want to implore you to make sure you watch this to the end of the class. So by the end of this class, you should be able to see a compound and you'll be able to say, oh, this is an acid. If you see a base, you should be able to say this is a base. If you see a salt, you should be able to tell us this is a salt. So I will be telling you for the acids, there are three basic theories that you need to understand that defines acids and bases. I'll be simplifying these three theories for you if you can just follow to the end of this video. If you have not subscribed to our channel, do well to subscribe to our channel right now. You can hit the subscribe button and hit the like button as well. Alright, so you're welcome back. So let's talk about acids. If I ask you what is your definition of an acid, you know, a lot of students will tell us an acid is a substance that dissolves in water or ionizes in water to give hydrogen ion as its only positive ion. And they will tell you a base is a substance that ionizes in water to give hydroxyl ion or hydroxide ion as its only negative ion. Yeah, that's perfect, very correct. But for your JAMB exam, you need to know beyond those definitions. That is actually one of the theories. That is the Arrhenius theory, right? So you need to know the other theory. So today I will simplify the three theories for you. So come with me. So we are talking about acids, bases, and salts. I'll be talking about three different definitions. You have the Arrhenius theory. Alright, now what does this Arrhenius theory, how does this theory define acids and bases? So let us see. Arrhenius theory defines acid as, it says, an acid is a substance that ionizes in water to give hydrogen ion, that is H plus hydrogen ion, or hydrozonium ion, H3O plus, as its only positive ion. So let us look at this definition. An acid is a substance that ionizes in water or dissolves in water to give hydrogen ion H plus or hydrozonium ion H3 plus as its only positive ion. That is Arrhenius theory. So when a substance ionizes, let me give you an example. HCl is an example. If HCl ionizes, it's going to give H plus and Cl minus. So the presence of this H plus makes this compound an acid because it has the ability to give hydrogen ion when it ionizes. To ionize means to split into ions, the positive ion and the negative ion. And the way you say it dissolves in water to give hydroxonium ion. So if I react, HCl reacting with water, H2O, I'm going to have the hydrogen, so this will ionize into H plus Cl minus. This H plus will react with water and you are going to have H3O plus, and then you have the Cl minus radical left. So this H3O plus is what you call the hydrozonium ion or hydronium ion. Hydronium ion. So any substance that we ionize in water, alright, or dissolve in water to give you hydrozonium ion or hydrogen ion, as its only positive ion is called an acid. So let's see some examples of acids. Examples of acids. Number one, you have tetraoxosulfate 6 acid. Tetraoxosulfate 6 acid, that is H2SO4. You have hydrochloric acid. Hydrochloric acid is HCl. There is triazonitrate 5 acid, that is HNO3. There are several other acids, okay, H2SO4, HNO3, you have H3PO4, phosphoric acid, you have H2SO3, H2CO3. So other examples, H3PO4, H2CO3, they are all examples of acids, etc. Right? You even have a sulfonic acid, H2SO3. So they are all examples of acid. They will all ionize and they will give hydrogen ion as their only positive ion. That is according to Arrhenius theory. So let us look at what a base is according to Arrhenius theory. A base is a substance that ionizes in water to give hydroxyl ion. This is also called hydroxide ion as its only negative ion. That is a base. A base is a substance that ionizes in water to give hydroxyl ion or hydroxide ion as its only negative ion. So let's see examples. If you look at sodium hydroxide, this is an example. If this substance ionizes, it's going to give Na plus OH minus. So this is your hydroxide ion or your hydroxyl ion. So any substance that ionizes to give OH minus as its only negative ion is called a base, according to Arrhenius theory. So let's see what are other examples of base. This is sodium hydroxide. You have potassium hydroxide, KOH. There is calcium hydroxide, CaOH2. That's calcium hydroxide. Magnesium hydroxide, MgOH2, etc. All right. Now, these are hydroxides and they are bases according to Arrhenius theory. So before we go to the next theory, let me also let you know that bases are not just hydroxides, okay? Bases can also be oxides of metals. Yes, oxides of metals are basic oxides, while oxides of non-metals are acidic oxides. So if you look, if you take for example sodium oxide is also a base because when it reacts with water, it's going to give sodium hydroxide. So that is Na2O. So this is sodium oxide, right? This is an this is a basic oxide because it's a metallic oxide. K2 potassium oxide, any oxide of metals, okay, calcium oxide, they have the ability, they can act as bases. They can turn red litmus paper to blue, acting as bases. While oxides of non-metals, like your sulfur 4 oxide, carbon 4 oxide, nitrogen 4 oxide, they are oxides of non-metals, they are acidic oxides, they can act as acids. They can turn blue litmus paper to red. I hope that is clear. So that is Arrhenius theory. Now let's look at the second theory. The second theory. Now, the next theory we'll be talking about is the Bronsted and Lowry's theory. So number 2, we have Bronsted and Lowry theory. So what are these guys? What's their definition of acids and bases and salt? So Bronsted-Lowry's theory says an acid is a proton donor, while a base is a proton acceptor. Now, stay with me to the end of this video. I'm going to give you a shortcut, right? I'll give you a key that you can use to remember all of these theories and their definitions and what's the concept behind their definition, how you can easily recall them. Alright, so Bronsted-Lowry says acid is a proton donor and base is a proton acceptor. So in this case, when we talk about proton, what are we talking about? They are actually talking about hydrogen here. So if you look at the hydrogen, the element hydrogen, it actually has the ability that is called isotopy. Okay, isotopy is the ability of an element to exist in more than one form, 2 or more forms, where they all have the same atomic number but different mass numbers. Same atomic number, different mass number. What am I talking about? So if you look at hydrogen, hydrogen exists in 3 forms. It has hydrogen 1,1, which is what you call protium, and this protium is also called proton. Then hydrogen can exist as deuterium, hydrogen 1,2, deuterium. Hydrogen can also exist as hydrogen 1,3, tritium. Alright, these are the 3 isotopes of hydrogen. But this protium, which is proton, that is what the emphasis is on. When these guys carried out their research, they discovered that every acid has the ability to donate this proton. So they came up with the definition that an acid is a proton donor. So let's see an example of what that is. So if you look at HCl plus, let's take H2O for example. If you react this with this, now this is going to ionize to give you H plus here minus, and this acid is going to donate this H plus, donate it to water. By the time it donates it to water, you have H3O plus, and then you have Cl minus. So by so doing, this HCl is acting as an acid, a proton donor. It has donated proton to water, and you have H3O plus. While this water is acting as a base, accepting the proton that was donated by hydrochloric acid. Okay, so it's a proton recipient. Let's see another example. If you have HCl plus ammonia, ammonia is a base, okay, HCl is an acid. If you ionize this HCl is going to be, it's going to ionize to give H plus Cl minus, then the CH plus will be given to this base, and at the end you have ammonium ion, right? And then you can have chlorine here. So this is ammonium ion. So this base has acted as a proton acceptor. It has accepted proton from the proton donor, which is the acid, and therefore that is Bronsted-Lowry's theory. Now here's the question: water, is water an acid? Is it a base? Is it a salt? Or where do you classify water? What would be your response? Okay, I know you want to say because you drink water, you bathe with water, that water should be neutral, right? But I put it to you